Hey everyone, welcome to learn the algorithm with me together. Today let's take a look at 1 to 9, some roots to leaf numbers. And what is this problem talking about? We'll be given the roots of a binary tree and containing the digits from 0 to 9 only. And each root to leaf path in a tree represents a number. For example, like the root to leaf path 1 to 2 to 3 represent 1 to 3, and return the total sum of all root to leaf numbers. The test case are generated so that answer will fit in a 33-bit integer. Okay, and what is the leaf node? A leaf node is a node without any children node. All right, and here's some examples. Let's take the more complex one for the example one. Here, now we have the tree like starting from 4, 9, 5, 1 here, and also that's the 0. And now, first of all, we need to know what is the root to leaf path, right? It means that when we are starting from the root is, for example, 4, and what is the leaf? The leaf is the nodes without any children, like this 5, 1, and 0. And now we are starting from 4. How we get to the leaf node 5, right? So the way how we get to it is like from here 4 to 9 and to 5, and now we construct the numbers like 4, 9, 5. And how about the next one, like from 4 to 9, and if we're not going to left, we can go to right. How we see this? And we will get 1, that's 4, 9, 1. And also if this is from going to right side, it's 4 to 0, that would be like 4, 0. And we sum up all of these numbers, that would be equals to 1026, right? So this is the idea how the problem we need to solve, and it means that how we construct these numbers, right? Like the 495, 491, and 40. So what I'm thinking is like we can use the DFS. Why? For example, like if we are go to one level to another level, for example, like if we are working on the root node at this level, the numbers we have is now is 4, right? And when we are going to next level, then we meet 9. And at this level, what I wanted to do is like 4 times 10 and then at 9, then I will get a new number like 49. And then after we get 49, we go to next level. At a new level, what we do again, exactly the same, is 49 times 10 and add 5, and then I will get 495. And after we getting this, yeah, we already done getting the root to path leaf, and we just go back to last level. And the last level is still having 49, and we can use 49 go to another. The right side is like at this side we can also have 49 times 10 at 1 when we can get 491. And after doing that, we go back the last level and go back, and then we start to go to our right side. And at right side, we have 4 times 10 plus 0. So every time when we are working on the current level, what we do is like working at current level is we calculate the new number. How we do that is the numbers equals then to the original numbers times 10 at current nodes values, right? And after doing this, we go to next level, right? And then we go to left, and also if we are go as deep as we can, and when we stop is once we are already reached to a null, there's like no node, we have to stop. So when we stop is if the node is null, then stop, right? And if not null, we just calculate the numbers. After we calculate the numbers, now we also need to check if it is already reached to the leaf node, right? So if the node is leaf, what we're gonna do, we need to add these numbers. Right? And we need to add these numbers to our sum, or could we just return it? For example, like we get these numbers and then add to the sum and then return the sum to it, so that like what we return from. So every time we just pass the parameters to next level, and also what we call it is like how we understand it is this is what we pass as a parameters, but we go to as deep as we can, and then like for example at each levels like this 4, 9 and 5, and this is 1 and this is 0. So every time for the current node, I just ask it's like, hey, what's the sum of you? And the node 9 doesn't know that, and it will ask the 5 like, hey, what's the sum of you? So it will returns like the 49 5 to it, and then he also asked about the right side and ask him like, what's the sum of you? And it will tells her is like 49 1, right? And after he get the left sum and right sum, it will just calculate the sum of it is the 495 plus 491 and get the sum and just return back. Also the sum of it will be like 986, and then ask the left side what's the sum of you, and it will tell her is 40, and then it will do the calculation is 896 plus 40. So every time when we reach to the leaf and we return the sum of it, so we don't have to, so it means that there's no, it's impossible that we will reach the null node, right? And as I said, it will ask its left side to get the left sum from the nodes left, and also get the right sum equals to the right. And if it is I mean the leaf node, we can just return the current numbers to it. And after we get left sum and right sum, and return like left sum plus 2 right sum. So this is the idea how I solve this problem. Like every time first I will pass the current number I calculate, and then pass it until we meet the leaf nodes, and then when I got the numbers, I just return it back, and return it back as the left sum, and also I will ask the right side like what is the sum of you, and I will return also the numbers I have, and then I calculate it, get the total sum of the left sum and right sum, and then come back to the previous node. And the previous node is also ask the left side, hey, and how about you, and also return the sum of it. So after doing this, I just return our back to our root nodes, and that's how we got this. And solving use this DFS was the time complexity, because we need to go through all the nodes, so the time complexity will be O(n). N means the number of the nodes. And how about the space? And the space is just the height of the nodes. And that's it. And let's move to the coding part. Alright, I forget to remove the previous one. Just remove it. Now we start to do the coding part. First of all, we need a DFS as a helper, and we pass the node, and also the current numbers I calculate, right? And I believe that's it. And then we start to work on it. At this level, what we need to do is we calculate the numbers equals to numbers times 10 and plus the node's value. And then if it is a leaf node, I mean the node's left equals to null and node's right equals to null, then we just return the number. Else, like, not else, I mean just we start to, like, as the current node, we ask our left child or right child, like, hey, like what sum you got, right? The left child will returns like DFS node dot left, and then we move to next level, pass the current number we got, and so does the right child. If right sum and go to right, and also pass the current node. And after we get all this, we just sum them up and tell our parents like, hey, that's what I calculate, right? And this is the part I'm working on the DFS. And now going back to the main part, and we can just return the DFS, because for the root node, it also like us is child, and the numbers it had for the at the starting point is just 0, because when we move to the next level, starting from the root node, it will start to calculate like 0 times 10, and at the root node's values, that's how we get. And also we need to check the corner cases, like if the root node is null, right? We are returning 0 because nothing there. And I believe that's it. Let's run it. Cool. So all the tested case pass. And how about adding like current case, for example, like there's no node, what will look like. Alright, so we at least have one node, so it doesn't matter. Alright, there's something wrong. Cannot read the file value where, so because it is now. Alright, so now if the left node is down, what can we do? So it means that the node left is not none, then we ask our left children. If we don't have that, we cannot do it. Or probably like we are checking the null node here. If the node equals to null, we can just return 0 because nothing here, right? And we can probably add these test cases and test again. Cool. Yeah, it passed all the test cases. So how we solve this problem is like we have to fully understand how we use the DFS. Like we can pass the number we calculate at current level, and also we need to fully understand like what we are asking our left child and right child. Like I asked my left child like how much you got at total sum, and it will tells you, and then I will do like the final step, like to combine the result from my left child and right child, and that's it. And the numbers we pass to next level, when we are done from the next level and going back to current level, the numbers still maintain the same, so we don't care about that. Like this, if we go to fork and go to next level 49 and go to next level 40, get 495, we go back and at the level 2 it's still the 49. It doesn't make any changes, right? So I think that is for the new beginner. Probably they are confused about this, which we need to pass and what we need to return. And yeah, that's it. If you feel like if you learned something from this video, please give me a thumbs up. That would be great encouragement for me. And yeah, that's it. And see you at next video.